completed with deep learning, and we started the AI development frameworks. So these are the framework that we use when it comes to deep learning in terms of training our model. Okay. So there's many frameworks. So basically, frameworks are just helping you to build this model without having to worry too much about the details of the algorithm behind. Let me just make sure I am recording this. Yes, I am. Okay, I'm recording that. Okay, that's fine. All right. So, so basically, we use these frameworks. There's many frameworks. We use them based on what we're really trying to achieve when we're building our models. So the frameworks will help you build the models in such a way that you're not really paying too much attention to the details of the algorithm. So what is when we look at the development of neural networks, so we have a lot of things that we need to do. So it's take a lot of time. We're dealing with training large amounts of data, and it really take a lot of time to really do that. So you don't want to waste time in creating all these algos there, while there is frameworks that can help you and get the code easily. So we look at different frameworks such as PyTorch, which was created by Facebook or Meta. Okay, then we have things like TensorFlow by Google, MindSpo, which was created by Huawei. I think Paddle is created by Baidu or something like that. Yeah. All right. So the deep learning framework will help you build neural network, as we mentioned that. So we can basically use existing models to configure parameters as required and train the model automatically. Okay. Instead of you trying to create a model, you create all these layers of the neural network. You can use this framework to try and build that as simple as building blocks. Okay, so in the current market environment, we have framework, as I mentioned, TensorFlow, PyTorch by Facebook, and then we have MNext by Amazon. We have Paddle by Baidu and MindSpo by Huawei. So when we're looking at these platforms, they are all working differently and using, in terms of the computation or computing power. Remember, on the 4 elements of AI, we have data, algorithm, scenario, and computing power. So when we think about the computing power now, this is where the computing power comes when we're training the model. So the better your computing power, the better your model are going to train. So if you try, for example, to create a simple model on your computer and then you start training it, then you realize that your computer GPU is being overused as it's training the model, and sometimes even the temperature of your laptop will really increase. So now when we're building big models, we have a large data set, we have a lot of things that we need to do. It's very difficult to just take a simple laptop and train those type of models. That's where you will need more of your GPU and CPU of your device. So you have your GPU. Guys, what does GPU stand for? What is GPU?
Graphical Processing Unit.
All right. What about CPU?
Central Processing Unit.
Yes. And what about NPU? This is the neural processing unit. So basically, your NPU is basically what you can call the AI brain of your of your device, right? The AI brain. So this chip is the one that is used when we're dealing with devices that will be uh, training the models and everything. So the NPU is the one being used as well when you're dealing with neural networks. So that's why it's called the neural processing units. That's something that you can add to the device, okay, if the device doesn't have it. So this is like the brain of your it's like the brain of your device, okay. So this type of chip is really specialized in I can say accelerating AI and machine learning tasks, right? Like building neural networks and deep learning, okay. So we can, when we look at some these type of chips, they are designed in such a way that they can be able to run all your AI workloads with low power consumption. Okay, and it's mostly, you find it mostly in your cell phone, because remember your phone, you have many apps that are using AI, starting from your facial recognition, right? So you have in the phone, you will find a NPU, a neural processing unit, which is doing all the AI workload. Okay, so you find it in your smartphones, in your IoT devices, Internet of Things devices. So all your devices that make your house be a smart house, you know. You find it in some cameras that have AI enabled. So basically AI enabled cameras. So you find your NPU there. Okay. So an example of on your phone, when you using Siri on an iPhone, you always have Siri. So the fact that Siri is an AI there, you need an NPU, which will be processing all the AI workload there. Okay, you have your facial recognition, you have your real-time translation where you can ask your phone to translate something. Okay, you have your camera. Sometimes your camera has to detect people's faces and try to zoom in, zoom out, all those things. So that's what you have for your NPU, right? But now, when you look at some at the CPU, the GPU, right? So if this NPU is, if the NPU is the brain of the device, the GPU will be considered to be like the muscle of all the graphics and all the computing that are happening in your computer, right? So normally the GPU was originally designed just to deal with graphics such as when you're playing video games, you're watching videos, and all the graphical interfaces that you have. Uh, but now with machine learning and all these data, the GPU is now used more as well for all those activities, which we call parallel computing. So everything that is happening behind all those calculations being done by the machine, by all your models that you have, are also using the GPU. Okay, so the advantage with one of the strengths of the GPU is that the GPU can process thousands of operations at the same time. That's why we call it parallel processing. So there's many operations happening at the same time. This is the reason why you find that you're watching a video. If you try it on your computer, open Netflix, open YouTube. Now there's so many things working. You will see now your computer is getting slower. You touch your computer, the temperature is increasing. You must know it because of the parallel processing that is happening in your GPU. All right. So GPU, as I said, used in AI, videos, gaming, and all those things. Now, when we talk about the CPU, so the NPU is the brain of the device, usually found on our phones. The GPU is the muscle of the computer, and then we have the CPU, Central Processing Unit, which is basically the brain of the computer. So the CPU is just a processor that you find on every computer. It helps you with running the whole operating system of the computer, all the operation that are happening between softwares, managing all the system operation. Okay, so it's a very flexible processor there. Okay, so it's very good at handling single task. You know, but it's not good when it comes to parallel processing and all those things. Then the GPU comes in. Okay, so you must just understand, if you have something like, let's say you open your Microsoft Word, your Microsoft Word will use the CPU. But if you open your YouTube, the app itself, yes, because it's a software, it's using your browser. Basically the browser is going to be using the CPU, but the fact that you are watching things that have to do with so many graphics, now the GPU is coming in. All right. So that's even the reason why when you have your phone, you are spending so much time on apps like Instagram, where there's so many graphics going on. You have other apps in the background that you can see the temperature of your phone as well increasing because the GPU is being used. All right. Any question, guys? You can stop me anytime and ask if you have anything to ask. Okay. So these mainstream computing processors are going to be used whenever we use any of these frameworks. All right. So let's speak about the frameworks now. We have PyTorch. Remember, we said PyTorch framework created by Facebook, right? Or Meta as a company. Okay. So PyTorch is a framework, as we said, it's computing it's a computing framework for deep learning used to create models. So when we look at this framework, it has different how can I call it, different features, right? That's PyTorch use. But you need to understand that PyTorch, number one, PyTorch is open source. Open source, that means that it is free, right? It's one of the most popular tools that is really used by researchers or developers, okay? Or many companies that are building artificial intelligence or machine learning models. There's many companies that are using PyTorch. Okay, so it also has it has some libraries, right? Some libraries that you can implement in PyTorch in order to do certain tasks. And you must understand it's PyTorch is a tensor library optimized for deep learning using GPUs and CPUs. Okay, so other companies that are built using PyTorch as well. You have companies such as Twitter, GNU, and other companies. Okay, so here are the features of PyTorch. Must understand PyTorch. In PyTorch, we say Python first, so which means that it prefers Python. So it builds on Python as a programming language. Okay, so it can also support some other programming language, such as the C++. Okay, so basically, when we look at this now, we can see that it is a framework that is really easy to debug. It's easy to learn PyTorch, right? And it's very easy to debug, so you can check your errors and all those things. Okay, so those are some of the features of PyTorch. So you need to know PyTorch can help you build, train, and deploy all your AI model. Okay, so the code in PyTorch will feel just like normal Python code. Okay, so it's very easy to use it. Okay, and when we talk about these dynamic neural networks, yeah, it's because all the what we call computation graphs are built as your code is running. So as you coding, you can build all these graphs. So the computation um, graphs are built as you moving, then you build your graph, which means the whole structure of your model, which was a problem with TensorFlow, as we're going to talk about TensorFlow as a framework. TensorFlow 1, because in TensorFlow 1, you are required to build the graph at the beginning. So at the beginning of the app, you have to build all your graphs. But we're gonna talk about it. What does it mean to build the graphs? But when you look at PyTorch, PyTorch does not have that issue there. Okay, so TensorFlow, another open source machine learning platform, which was designed by Google. At the moment, we are on TensorFlow 2, so you can find TensorFlow 2.1, 2 point something. But when you look at the TensorFlow 1, that's what I was saying, that TensorFlow 1, there was an issue of the graphs, right? So basically, we had what we call static graphs, which you have to define your graph first, then you can run the app, the rest of the app. So now in TensorFlow 2, we don't have that issue. So this is an example here. So in TensorFlow 1, we actually have to, let's say you want to just add two numbers. So you have X, Y, and then you want to add the two numbers. You want to do an X plus Y, right? So Z will be equal to X plus Y. So when we look at this in TensorFlow 1, what we had to do here, you have to, so basically here, we have this will take the first inputs of the first value, where I actually have to declare the type of data that I'm using there and everything. And then I have to build the session. So this is the graph. So I always have to do this before I can actually get to the operation. But when we look at TensorFlow 2, I just have to say this is a constant, is a value, and then Z equals X plus Y, and then I can print that answer. Simple as that. But now this is what we are avoiding. You have so many code that you have to do in TensorFlow 1. Okay, and TensorFlow 1 was really hard to debug because of these type of issues, because of the static graphs. Okay, but TensorFlow 2 is easy to debug. Okay, so this is TensorFlow. Now in TensorFlow, we can also implement other libraries such as the Keras library, which is a library that can also help everything, help you have everything really fast and have some code that can help you build your model easily. Okay. Okay, so these are the disadvantages of TensorFlow 1, which I've mentioned already, because of the graph that you have to always create. Okay, and TensorFlow 1 is really difficult to debug. Okay. Okay, so in TensorFlow 2, it comes with an advanced library called Keras. So the Keras library is a really high-level API that will really help you with building your models, right? Okay, so the third framework will be MindSpo. Okay, so MindSpo is a framework which was created by Huawei, right? So it is a framework uh, that is really used by many companies as well in building the models. Why? Because with MindSpo, you have, for example, you can use a certain model that you are training using TensorFlow. You maybe have TensorFlow will give you maybe 2,000 lines of code, but you do the same thing with MindSpo and it gives you only maybe 600 lines of code. That's one of the advantages with MindSpo, because everything is being done in in just a few lines of code. Okay, so you need to understand MindSpo is also an open source deep learning framework which was developed by um, which was developed by Huawei, right? So in terms of the computing power where MindSpo is, you need to understand MindSpo as well is using all your NPUs and everything. So you have Huawei Ascent processors that can use with MindSpo, right? It's easy to develop your systems, your model with MindSpo. You have an efficient execution, and we have what we call an all scenario coverage. So an all scenario coverage means that MindSpo can be used into different environments, from your mobile phone to your cameras, smart cameras, and all those things, which we're going to look at here. Okay, so basically, MindSpo will help you build all the machine learning and deep learning models. If you're dealing, for example, with image recognition, speech processing, natural language processing, so you can basically train these models on different hardwares, right? But remember, you are also using all your processors, your CPUs, GPUs, and NPUs. Okay, and then you can deploy those models on the cloud. When we're going to learn about cloud computing, we're going to see different ways of cloud, okay, different type of clouds and the technology behind cloud, but we can deploy that on the cloud, okay. And then you can deploy it as well on your mobile phone, okay. So remember, when we say we call MindSpo a all scenario platform, when we call it an all scenario framework, what we mean by that is it runs on cloud, right? Edge and devices. Okay, so what does it mean? It means we have MindSpo, which is built um, uh, for all these. So it's basically use Python as well, similar to TensorFlow and PyTorch. It has a really high performance, and it's run on all these scenarios here. So we basically have MindSpo on the cloud here. When we talk about the cloud, so we have all the cloud servers, the data center here. So we have all these servers here. So here, MindSpo, what does it mean? Is that MindSpo will run large scale training and inference. Well, when we talk about inference, we're talking about a model that has already been built. It's now working, it's running. So as the model is running, there's still AI operation happening. Because remember, let's say, for example, you are using your AI in a mall where you have to detect images of everyone in the mall and try and identify people's behavior. So when we have an issue like that, you need to understand that as the model is working in real life, there is still AI processes happening because those data needs to be processed. The reason why we talk about cloud, because you're not going to have all these operations happening on site. So sometimes you have to save all this information at a different location. They're happening in different locations, and the whole process has to happen in real time. Or else, by the time your system identify maybe a thief somewhere, it's already too late. The person has already gone. So everything needs to happen in real time. Okay, so basically, when we talk about MindSpo working on the cloud, it means that it run all the large scale training and inference on high performance hardware. So those hardware can be the GPUs and NPUs. Okay, so that is what will happen there. And then we have, when we talk about edge, so on edge, we talk about all the routers, right? You have your routers, or all your gateways, your controllers, okay? So when you have, in this case now, MindSpo is going to run the AI inference on edge devices that are closer maybe to the data source. So this is maybe you have your data that are on site. So all these edge devices here, okay. For example, we have a real-time object detection on an edge gateway in a factory. So you're working somewhere in a factory, and then we have something that is detecting different objects in the factory there, okay. And then we have the third option, the third one, which is the to run on devices. So you have all your smartphones, smartwatches, Internet of Things devices. Okay, so these will run small some AI models on individual devices. Okay, so for example, you have your face recognition, your voice assistant on your smartphones, and that. So when you look at that, you understand why it's called whole scenario. This this is what it means. It means that it can run on edge devices and cloud. All right. So this is the so just to understand that, you need to understand the language used by all the three framework. It's mostly used Python. Okay. And then in terms of the hardware focus, you need to understand your CPU, GPU, and NPUs are used, right? In terms of the developer who created this framework, Mindspot was created by Huawei, PyTorch was created by Meta or Facebook, and TensorFlow was created by Google. All right. Um, and another thing, the type of scenarios where you're going to use this, you're dealing with email recognition, natural language processing, and all these all these models that you can think of. All right. So, in terms of the Mindspore architecture, this is the architecture of Mindspore. So basically, on the lower layer, we have a diversified hardware. So we have all these hardwares here. These are all the servers and the routers on edge. So on cloud, you have all your servers. On edge, you have your routers. And on device, you have your smartphones, tablets, smartwatch, and all this. So you will deal with what you call that, with all scenario framework, right? It also have a multi-domain expansion. So basically, with Mindspore, we can use, when you look, for example, you have this library, which is just a library for models. It's called Model Zoo. So on Model Zoo, you can deal with things that are related to audio, all your computer vision, and then you have your natural language processing. Okay, so all these systems are going to be used there. So it has a really good developer friend. It's really good in terms of your neural networks, your data sets, so you can train. So basically, as you are using the platform, you have all these, which can just be some options that you click and then you create the neural network. So you have your syntax that you use. For example, you have a certain syntax that you write just to build the neural network, which can be just one line of code. You don't have to spend so much time and trying to build so many code. Okay, so that's how Mindspore will work. Okay. Right. So I think this will be all for today. Looks like it's was a lot of theory. Any question? Any question on what we spoke about today? Any question? Any question, guys? Is there any question? Yes.
Yes, I do have a question. I just want to know, right? All of that CPU, GPU is used to actually train the model, right? But what happens when the model is already like working? Let us say like facial recognition, like on the phone. Is the system already like installed, like your, what do you call this thing? The NPU, like is it installed in the phone, or is there another way
Yeah.
of?
Remember these are not uh, these are not, how can I say it? These are not softwares. These are hardwares, which means that they are installed on whatever device you are using. So if we on your phone, I'm gonna give you, wait, what example can I give you? Okay, have you ever had a phone that freezes? Have you seen a phone that is like somehow it's frozen, it's stuck on some screen, and then you have to switch off the phone?
Yes, I have.
Yes. You know, in that case, for example, it can happen that a certain app is overusing the GPU or the CPU, let's say. So because that app is overusing the CPU, now you find out the whole device cannot work anymore. So the CPU is in charge of looking at opening all the apps and all those things, the operating system of the phone. And then you have the GPU that will focus every time that your device is doing anything that require any parallel processing, anything that has to do with graphical images and all those things. And then you have your NPU, which will be used if on your device there is anything that has to do with neural network, anything that has to do with AI. So it's basically the AI brain of your device. So now, to answer to your question, if your phone come with a system of facial recognition and anything that has to do with AI, that phone will have an NPU on it, or else it's gonna be a problem, or else you're gonna try and unlock your phone. It's taking 5 minutes to unlock your phone. Because you need to understand one thing. We've done CNN. Remember in CNN what we've done? We spoke about an image being taken where we take all the information about the image. Every single pixel of the images is put in the network for your system to be able to identify. Now, remember, that was the learning process. Now, in terms of in real life now, when your facial recognition is working, it doesn't just unlock the phone like this. No, it does the same process. It takes your face and put it in a network. It put it in a model, I mean, because when you build your network, you build that model. And the model is a very long mathematical equation, which will take as input all the features of your face. So now this time your phone must, every time you want to unlock your phone will get all this information, put them in the same model and detect if it's you or not. So it has to detect a certain percentage. Let's say, for example, when they create the phone, they put it that if it can detect, if it can match at least by 89%, it unlock. If it's less than 89%, it shouldn't unlock. So now when you look at something like that, you can see that now your phone really needs to have an NPU so it can deal with that in 1 second. That's why you unlock your phone in just a second. You understand? So that's the thing. So those are just CPU, GPU, NPUs. Those are chips. Those are processors that you can actually see. So those come with any device that you have. So any device that will need to use any AI will need to have an NPU. You see. So another example I can give you. Let's say, for example, you have a smart camera. We call them smart camera, but sometimes it's not the camera that is smart. Sometimes it's just that the camera needs to get the image and send the image to a different location where there is actually maybe a certain server where there is actually all these AI tools that will process those images. You understand? So when you look at that now, whether it's in training or in during in production, you need all these chips. So these chips will come with any devices. Okay. Did I answer? Did I answer properly to your question?
Yes, you did.
Yes, yes. Okay. So, and another example I can give you, for example, if you're using, if for example you are using MindSpore, like you take the first step, maybe you train a speech recognition system, a speech recognition model, right? So you basically train it in the clouds using powerful NPUs. Why am I saying in the cloud using powerful NPUs? Remember what we said about MindSpore. So if you, let's say you are not able to afford this. So this is what this means. This device is a very expensive device. This is very expensive. All these devices are expensive. Let's say all you can afford is just a camera to collect the data. But how will you be able to train this type of model without having the money to purchase all this? That's when now there is a way, for example, with MindSpore, where you can, let's say you can subscribe to, there is certain services provided by companies such as Huawei, where you can basically just connect your data, which will be sent to the cloud, to a Huawei cloud, where you basically using their devices to train your model. You understand? So, like in the case I'm talking about, you train a speech recognition model in the cloud using powerful NPUs because you don't have them with you. So you're going to train them with the cloud, and then you deploy the trained model to a smart speaker, which will be able to process all the voice commands locally in your house. But when you were training that, you used powerful NPUs from another company via the cloud, right? Now, what will happen now is that now you've installed the model on your speaker at home. Now the smart speaker sends all the user data back to improve the model. So every time now you are using it, you can update what's happening on the cloud now because your model is learning with real data now, right? So that's the thing. So when you look at a smartphone, it can run the same model that you built to be able to enable all the voice typing when you are offline. So basically, even if you are offline, because your model has already learned from the data. Okay, so you can run all these on just the framework MindSpore. See, so that's how it works. So that's why it's called an all scenario AI framework, because you can actually, you don't have to afford all these devices to build a model or to use a model. Okay, guys. Any other question? Any other question? All right, guys. Please, as we can just put on your cameras, we'll take that.